world of manufacturing is constantly at work, seeking new ways to improve and streamline operations. One of the most remarkable materials playing a significant part in forming tomorrow's manufacturing future is a sturdy, reliable substance that can easily transform into any shape or size. It's called plastic.
We are living in an age of rapid change. The shapes which surround our daily lives are constantly evolving. The presence and importance of dyes in our lives can be shown beginning with an ordinary morning. Everything around us has been created using dyes, yet very few people are aware of the significance of dyes in our daily lives. Dyes play a key role in the creation of the products which comprise our modern lifestyle. Through the passage of time, our standard of living has improved dramatically. The automobile is an example, an item which has become a necessity of modern living. An automobile is composed of more than 20,000 parts. The production of that car involves many varied processes. Here, we see one of those processes, a press machine used to form body panels. Pre-cut sheet metal is inserted into what is called a transfer press. Individual body panels are then formed. This is the heart of the press forming process. Further details of press forming will be shown later. Think of the tire. During tire production, liquefied raw material is poured into a mold and subjected to high pressure to form the tire. The computer she is using is composed of various electronic components. The tiny parts used in ICs are also made by press machines. A computer requires a variety of precision parts, including the lead frame of an integrated circuit chip. Let's look at the production line of a lead frame. Lead frames are generally punched from metal stock 0.2 millimeters to 0.4 millimeters in thickness, at rates ranging from 800 to 1200 parts per minute. Press forming is also at the heart of this example.
Hi everyone! Inside this watch are tiny, tiny gears. Can you believe how small they are?
The small gears of the watch she holds are made by a plastic injection molding process. These precision gears and other parts with detailed features such as models can be formed in one step. This is an injection molding machine. This is the raw material. Raw material is put into a hopper and heated in a cylinder until it melts. Molten material is then injected under high pressure into the mold cavity of the die set to form the part. The die set is the heart of the injection molding process. Here, we see a flower pot, which is also made of plastic. However, it is made by a process known as blow forming. The pot we saw in the apartment was made by this blow forming machine. Like the injection molding process, plastic raw material is placed in the hopper, heated, and molten material is pushed out. The tube of material is pinched closed at one end, and air is blown into it, causing it to expand. This is what gives the blow forming process its name. The part is then formed under pressure. The excess material around the pot will later be cut off and recycled. A die is also at the heart of the blow forming process. The hollow products made by the blow forming method are typically strong and lightweight. Plastic bottles and containers are typical products which take advantage of blow forming techniques. Bottles such as this one can be produced in high quantities.
Psst, over here. Would you look at this model? This dune buggy car consists of all these parts. Plastic, rubber, and metal materials make up these parts. To form these parts, various types of dies are required. All these parts came from somewhere. The die set is the mother of those creations. Let's look at die sets through history.
Our modern lives are surrounded by many products, most of which come from dies. The forerunners of today's dies can be seen by looking back to ancient Egypt. An ancient Egyptian wall painting shows people making tools with castings. Thousands of years ago, many people in other parts of the world were using dies to make ornaments, coins, copperworks, and earthenware. Though the shape of dies and materials used have evolved along with the progress of technology, the basic principle of the die is still the same.
Like I said before, dies are everywhere. Now can you see just how important dies are? Can't you, Mai?
Who, me?
Yes, I'm talking to you, Mai.
How can the TV be talking to me?
Around you are many things of various shapes and materials, which require a variety of production methods. Most of these methods involve dies, and obtaining the proper die is a vital step in the production of parts.
What? Okay.
Why don't we listen to a conversation between a person who ordered a die and the engineer who designed the die?
The car part that the designer had in mind was transformed by the engineer from concept to reality exactly as he intended.
I've worked hard for several months to see that every detail is correct. I'm glad to see that you are satisfied with the results of my hard work.
Now that we've shown you a little about dies, don't you find the world around you a little more interesting? Hey, Mai, why don't you come with me and we'll learn more about dies?
Okay.
Well then, let's look at the various kinds of dies and molds.
The type of die used depends on the shape of the products and the material being used. The different types include press dies, dies for forging, casting, plastic molding, powdered metal molding, and many others. This is a die used for forming lead frames. 10 different processes are performed at the same time by one press. During press forming, material is under high pressure to form the desired shape. A precision die can produce finely detailed shapes, such as lead frames. This is the injection mold used for making plastic models. Notice how you can see the shapes of the model car parts by looking at the mold. During injection molding, material melted in the cylinder is injected into the mold. The screw is then drawn back. Material for the next injection enters the cylinder. The dies separate and the finished product is released. This is the blow-forming die used to make a flower pot. This side of the die makes the inside of the pot, and this side makes the outside of the pot. Detailed curves create the surface of the pot. Therefore, the quality of the die determines the quality of the product, as well as the efficiency of its production. During blow forming, air is blown into the raw material. The part is formed under pressure within the die. The processes for making dies involve a great deal of machining technology. The processing steps include initial planning, conceptual design, detailed design, production planning, raw material preparation, machining, heat treatment, finishing, assembly and adjustment, and trial production.
The first step in the making of a product is the making of the die. The first step in the making of a die is the die design.
In the production of a die, the design is very important. Die designs vary greatly depending on factors such as the raw material to be used and the production conditions. This specialized die must function in combination with the forming machine. The design of the die requires specialized knowledge of all these factors.
Today, the making of dies is assisted by computer-aided design and computer-aided machining systems, commonly called CAD/CAM. These systems contribute greatly to cost saving for design work and automation of the production process. Computer simulation systems, known as CAE, simulate testing of finished products. Computers contribute greatly to die making. These computers are CAD workstations. Look at this. Here she is using CAD in her design work.
The CAD system helps engineers automate the drawing function. On the screen, engineers can see a clear image of the product or die that they are designing. When designing similar products, an engineer can borrow computerized drawings and data from previous designs. CAD systems are powerful time and labor-saving devices. Data accumulated by CAD systems can be transmitted to CAM systems, either online or by magnetic media. Upon receiving such data, CAM automatically operates numerically controlled machines, such as machining centers. With the aid of CAM, machines can work unattended. Today, CAD/CAM systems have become indispensable for die making.
CAD/CAM certainly is convenient for both the design and production of dies. Next, we'll look at die machining, which can be divided into 3 categories.
The 3 machining methods are cutting, grinding, and electrical discharge. Depending on the finished product, the die must be machined to precisions reaching the micron and submicron order. The most suitable machining process must also be selected.
This is a machining center.
This machine can perform both milling and drilling operations. The die material to be machined is automatically selected and transferred to the machine. An automatic tool exchange system provides the proper tool. The machine then automatically performs the operation. The machining center is controlled by data transmitted from the CAD/CAM system.
This is an NC milling machine.
Using 3-axis, the NC milling machine automatically performs milling operations. Controlled by data from the CAD/CAM system, surfaces and grooves are precisely machined. In this way, 3-dimensional parts can be precisely machined.
This is a profile grinder.
This machine is for grinding die parts. The operator is tracing a projected image of the desired die shape. Although this machine is manually operated, this process can also be automated using the CAD/CAM.
This is a wire electrical discharge machine, or wire EDM.
The wire EDM operates in a manner similar to that of a bandsaw in that the work table moves. The wire is made from copper alloys with diameters ranging from about 0.03 millimeters to 0.3 millimeters. According to the data stored in the controller, workpieces are cut by the electric energy discharged from the wire.
This is an electric discharge machine.
Instead of using wire like the wire EDM, the EDM uses electrodes and electrical arcs to form the workpiece. Here you can see an electric arc at the tip of the electrode. Dies are machined into a shape opposite that of the electrode. These various electrodes are used to mill complicated 3-dimensional shapes. This is the tip of the electrode.
After going through the process of being machined, dies are then manually finished.
Intricate parts may require careful hand grinding. After dies have been hand finished, they are assembled into the forming machine to make a test part. Final adjustments and finishings are then performed.
Is it necessary to test the actual performance of dies after such a precision finish?
Oh yes, of course. In order to obtain the desired shape, dies almost always require fine tuning.
There is always the possibility that the finished product may have imperfections. Die makers must pay close attention to the end requirements of the dies they produce. These requirements include ease of installation, high productivity, low maintenance, dimensional reliability, and ease of use.
All finished dies must be in absolutely perfect condition. Slight deviations are not acceptable.
The standards that die makers must adhere to are really strict, aren't they? I didn't know that. It sure is complicated just to make one thing.
In today's die-making field, computer systems such as CAD/CAM and very sophisticated machining technologies are widely used. It's not an exaggeration to say that die making is an art form.
Even with the convenience of CAD/CAM, machines cannot do everything themselves. people are at the heart of technology. There is a large body of knowledge and experience concerning dyes, how dyes are used, and how they are produced. No matter how far machine technologies develop, it will always be people who utilize this knowledge.
The products made possible by progress in die-making technology will shape our future. Engineering achievements will enrich our lives.
In terms of technology, the Japanese dye industry is absolutely the very best in the entire world. Thanks to modern dye technology, we can create high-quality products efficiently and inexpensively. The dye technology, which is enriching our daily lives today, will continue making further progress to better our lives in the 21st century. The shape of things around us continues to evolve. Our future begins with the progress of dye technology. Engineers make the dyes which make our dreams come true.
A clock, consisting of many parts made with dies, is able to tell time. This tiny robot, also consisting of many parts made with dies, is able to move. Dyes play a significant role in making the things which facilitate our modern lifestyle. The quality of our products depends on the quality of our dye technology. The ambitious innovation of dye technology has a profound effect on dye-related industries. The dye industry hopes that by presenting this video to a wide range of people, a broader understanding and appreciation of the importance of dyes will be achieved.